we know that rational or fractional exponents really represent roots, right? Or radicals. So there's no reason why we couldn't extend this method to exponents that are, equations with exponents that are fractions. Oh, all right. So x to the 1/4 minus 2 equals 1. What is that really saying in radical lingo? X to the 1/4 is 4th root of x. So this is really the 4th root of x minus 2 equals 1. Well, that basic procedure, the first recipe, when we had a single root, will work here because this is a single 4th root. But you don't have to change it to the 4th root of x. You can think of it in terms of exponents. So what's the first step going to be? Isolate the x to the 1/4. So how could I do that? I could just add 2 to both sides. And what does that give me? X to the 1/4 equals, 3. Now, how would you, let me move this down just a little bit. How would you get rid of that 1/4 power? You have x, that's supposed to be an x on the left side. Let me make that look a little bit better. It's x to the 1/4 on the left side. You want just x to the 1 power, right? What could you do to both sides? If you think of it in terms of roots, it's the 4th root of x on the left side. You could take both sides to the 4th power. But you can also think of it in terms of powers and laws of exponents. So look, you could take both sides to the 4th power as you would do if you had this as the 4th root of x. And it still works if you think in terms of the laws of exponents. Look, on the left side you have x to the 1/4 to the 4th power. What happens when you have an exponent on the inside, exponent on the outside? You multiply. What's 1/4 times 4? Yep. You get x to the 4/4 or x to the 1. 3 to the 4 is what, 81? So it works in terms of exponents. You get x is equal to 81. And you could check it because you plug it back in, you know the 4th root of 81. 81 to the 1/4 is 3, minus 2 is 1. Easy to check. So those laws of exponents, we can use those for solving really what are radical equations, right? All right, so a similar idea in this one. Let's solve this. We have 2 times the quantity 4 minus y to the 1/4 power equals 6 to the 1/4, which is equivalent to having 2 4th roots, right? I'm basically going to follow the same set of directions that I followed for the second example. We're not dealing with square roots. We're dealing with 2 4th roots, 2 1/4 powers, which are 2 4th roots. But it's really the same sort of directions. We want to isolate the radicals from each other. The 4th roots, or if you leave them as powers, the 4th powers from each other, but they're already isolated. Now, instead of squaring both sides, we have to adjust that second step. What would we do to get rid of, think of this as a 4th root. Think of this exponent as a 4th root. What would we do to get rid of that? Take both sides not to the 2nd power, but to the 4th power. And again, I'm not gonna write it as the 4th root of 4 minus y on the left because I want you to get used to rational exponents. Okay, so what I could do then is, you know what, let me rewrite the problem so I'm not ruining the initial statement of the problem. So instead of taking both sides to the 2nd power, we're going to take both sides to the 4th power. Now, let's put in brackets the entire left-hand side and take it to the 4th power. Let's put in brackets the right side, or in parentheses, the right side to the 4th. The right side's easy. Let's do that first. What's 6 to the 1/4 to the 4th? Exponent on the outside, exponent on the inside. You keep the base 6 and you multiply. 1/4 times 4 is 1, so it's 6 to the 1 power, or just 6 on the right side. What do you have to be careful to do on the left side? You've got 2 times the quantity 4 minus y to the 1/4. The 4th power Remember, when you have a product to a power, then that power applies to both factors in the product. So you need to rewrite this left side as 2 to the fourth power. So this exponent applies to this factor and to this factor. So you need to write 2 to the fourth power times, 4 minus y to the 1/4 is the thing that's there originally, right? And then you're going to apply to that, you're going to apply that fourth power. Stare at that. Make sure you understand what I just did. Any questions on that? Okay. So, what is 2 to the fourth power here? 16. What is 4 minus y to the 1/4 to the fourth? What happens here? By design, you multiply, those guys are gone, and then you just have the base 4 minus y left, which you should leave in parentheses. It's the whole thing. Any questions there? Does that make sense to you? I kind of like to divide out like factors before I distribute. You don't have to do it this way, but what's the like factor you can divide out? Well, 2, right? Okay, I see where you're going. You could divide both sides by 16 to free up the 4 minus y. That would work. We could do it that way if you want. So I was thinking in terms of dividing out the 2 and then distributing the leftover 8. But okay, we'll do it your way. So if we divide both sides by 16, that doesn't always work though. The distribution method will always work. Doing this, if you have another y on the right side, this won't work. Okay? But here it does. It works great. So that we end up with what? 4 minus y is equal to 6/16. What does that reduce to? So not 2/8, but 3/8, right? And then we want to solve for y. Okay, can you do this in your mind? In my mind, I would move the y to the right side, actually. And move the 3/8 to the left, and then turn it around. What would you get? Y equals 4 minus 3/8. Yeah. Okay, if you get a common denominator, multiply 4 by 8/8, that's 32 eighths, right? Minus 3/8, which is 29/8. Maybe not so easy to check by hand, but does your calculator care that it's a fraction? No, so you could check that pretty easily in the original problem with your calculator. Yep.
So I went ahead and distributed the 16.
Yeah.
I got 64 minus 16y equals 6.
Okay. So wait. Let's take a look at that. So if you distribute the 16 here, so we'll do the alternate universe. We decided to distribute the 16. We get 64 minus 64y, 16y, sorry. 16y. It's this time of day I start getting tired of saying silly things. 60 is, yes. Okay, equals 6. Yes, okay. And then from there, what would you do? Okay, so if you subtract 64 from both sides, what do you get? Negative or positive? So negative, right? 58. So you get y is equal to, if you do the division here and the negatives cancel, you get, what, 58 over 16? But what does that reduce to? Take the 2 out of both factors. I think you'll get 29 over 8 that way as well. Okay? Either way.